Have you ever wondered how we confidently make decisions based on data, moving beyond mere guesses to robust conclusions? This precision comes from a powerful tool in statistics, which helps us evaluate hypotheses with confidence. When calculating a test statistic, there isn't just one universal formula, but rather a family of formulas, each specifically designed to address different types of data, research questions, and underlying assumptions. The most commonly encountered test statistics include the z-statistic, the t-statistic, the chi-square statistic, and the f-statistic. The choice of formula depends critically on the nature of your data and the specific hypothesis you are testing. For instance, if you are comparing means of large samples or if the population standard deviation is known, you would likely use a z-statistic formula. However, if you are working with small samples and the population standard deviation is unknown, the t-statistic formula becomes appropriate, accounting for the increased uncertainty. For examining relationships between categorical variables, the chi-square statistic is your go-to. And when comparing the means of more than to groups or analyzing variances, the f-statistic formula is essential. To effectively choose the correct formula, you need to first clearly define your research question and identify the type of variables involved, whether they are continuous, ordinal, or nominal. Next, assess your sample size and whether you know any population parameters, such as the true population standard deviation. These considerations will guide you to the appropriate statistical test, which then dictates the specific test statistic formula to use. Understanding the underlying distribution of your data, whether it is approximately normal or skewed, is another critical insight. Many test statistics relying on assumptions about normality, and violations of these can lead to incorrect conclusions. Statisticians also often refer to the concept of degrees of freedom, which is a key parameter in the t, chi-square, and f distributions. This value, derived from your sample size and the number of groups, adjusts the distribution to more accurately reflect the uncertainty in your estimates. Ultimately, selecting the right test statistic formula ensures that your data analysis is valid and your conclusions are reliable. By carefully considering your data characteristics, research question, and statistical assumptions, you empower yourself to extract meaningful insights and make informed decisions from the evidence at hand, turning raw data into actionable knowledge.